Right. So, like I said earlier, we have folks who, do cool stuff, and want to come like talk about it. Similar thing happened with Ian. He kind of went to DockerCon, and then he just pinged me. We're actually really good friends because we organize DevOps days together, and then we do some other meetup kind of stuff. And so he pinged me and he was like, "Hey, this DockerCon stuff is really cool," and I kind of wanted to come talk about it. I was like, "Well, we're gonna do a DockerCon recap meetup this week, so feel free to come by." And here he is. So without further ado, Ian's gonna do. I'm not gonna steal his thunder. He's gonna do some Swarm stuff. Let's give him a round of applause.
All right. This is based on 112, yes. And so I'll give you the background on this. Basically, the company I work for, we're looking to move the majority of our workloads to containers, and I've been working for a while just on getting Swarm set up and everything we're going to need to have this brand new infrastructure in Amazon, and we gradually transition to it. And I got everything pretty close to finished, enough that I was able to get it out to our dev team so they could start hacking away on it. And that was on a Friday, and then I went to DockerCon on Monday, and everything changed. So yeah, so that's where I'm at. So yeah. So what this presentation is about are those changes in 112, kind of how it impacted me, the things that I saw that I thought were neat, and hopefully you guys get some value out of this. All right, and hopefully my screen won't turn off. I bunched the cord up a lot. So yeah, Swarm mode. Got it. So if you guys want to view these slides, here's the URL. I'll throw this up again at the end, but you can grab these slides there. So I just want to throw out these key improvements real quick. Most of this presentation, kind of walks you through everything as if you had never used Swarm before. But I did want to throw this out for those folks that had used Swarm before, just so they could understand what were some of the key improvements that I saw during DockerCon that I was interested in. One of them was no external data store required. Before I had console up, and I was like, oh, now I'm going to have to cluster console and all this stuff in production. And now I don't really have to worry about that. There's an internal data store that's used that Lee was talking about in his slides, and that's great. Secure by default. I have an asterisk over here. So one of the challenges that I had when I was looking at the Swarm implementation was around the security. I was like, oh, I'm going to have to do all the TLS communication. I'm going to have to figure out, do I want this certificate authority here? What am I going to do as far as my certs are concerned? And now it's secure by default. But there are some changes here that have happened, and there was a issue that was brought up in the Docker GitHub issue forum where a guy was like, hey, the communication between these Swarm nodes is not secure. I see plain text going through TCP dump here. And then there was more communication, and apparently they've added a flag, so now it's optional where you have to say like opt secure. So I'm just throwing it out there because it sounds like they may be reversing on some of the secure by default and more of secure through optional now. I'm not really sure what's going to happen with that, but it is also a reminder that this is a release candidate and they are making a lot of changes. And I seem to find that it's best when you're looking at some of this to have the doc site open and to also have the GitHub issues open as well, because they're making changes a lot. I mean, this is RC3 that I'm basing this off of. They're already talking about things that are going to change in RC4. So. Automated key rotation, that sounds great from a compliance perspective. We're a healthcare company. We deal with HIPAA, we deal with compliance, and anything that makes our HIPAA compliance officer happy is good for me. So
is it also default, or you got to turn the flag on for rotation?
That,
set to 90 days or whatever.
My understanding is that that is default out of the box. There's automatic key rotation. I believe it's a tunable though. I think you can set some stuff up on there, but my understanding was it was out of the box. I haven't really dug into the key rotation and see what's going on under the hood. I know you can bring in your own certs as well instead of using the ones that are automatically generated within the Swarm.
Yeah, I'm still using my own, and it didn't have any burps on that.
Yeah, like I said, I haven't dug into that one, but I got the impression the automated key rotation was just there out of the box, at least some default value that was going to satisfy most customers. Rolling updates. This is one that was a nice perk. Health checks. I have not got into health checks yet, and I know one of the questions was if that applied to Swarm as well. I don't know. I thought it did, but I haven't actually experimented with health checks yet. Container native load balancing, this was another huge one. Like right before I left for DockerCon, I was playing with interlock, and I felt pretty good about it. I was like, hey, I've got it configured nicely. It's doing what I wanted to do. But it was, I mean, the documentation was a little sparse on it. It was definitely took a lot of time, and this is a nice, tightly integrated solution that I feel is going to actually work out better for me. So the container native load balancing is a nice perk here. Another one I didn't mention on here because I guess it is a 1.12 feature. I'm not really sure. Is the rescheduling the nodes on failure was actually in like 110 and 111, but it was an experimental feature, so you had to enable it explicitly. But now that's just built in. So I guess that is a 112 feature, but it was around before that as well. Some of these may have been before it in some capacity as well. All right, so grasping the basics. Oh, that's just killer right there. All right, Swarm. So let's talk about what this is. And I'm going to try to make this as simple as possible so that those of you that have never dealt with Docker Swarm can come away from this presentation kind of understanding a little bit about it. So a swarm is a cluster of Docker engines. And a swarm mode is native in Docker 1.12 RC. You can't use it in any other version. This is the first introduction of it. Before, you actually had to bring down a separate swarm container and configure it. But now it's built right into the engine. So if you have 10 instances and they all have Docker engines installed and you enable swarm mode, that is your swarm cluster there. When you're in swarm mode, you orchestrate services. Now this is a little interesting because with the older version of Swarm, you could go in there and just, hey, I want to run this image, and it creates a container and it schedules it on one of the nodes. So far, and I could be wrong about this, but so far it seems like you have to use services. Basically there's a blurb in the docs that states when you're running container commands, you're not in swarm mode. When you're orchestrating services, you're in swarm mode. So, so far, from what I can tell, if you just run a single container, you're just going to run it on that particular node, and it's not going to be part of the swarm. So that's one key difference there. Services and tasks. So a service defines tasks that are executed in the swarm. And basically, a service is an image and a command. So it's not really that different than something like Docker Run. I mean, you're still specifying, hey, here's my image, and that image may have a built-in command or entry point, or you can override that with your own command there. So, but you're basically just wrapping this up in what they call a service. And then a task is the scheduling and execution of a service on a node. So you create a service, you don't create a task, like say I create a service just called Ian, and I say I want to have 5 replicas of Ian, then those are the 5 tasks that are distributed across the swarm. Okay, and a node. So I know there was some question about what exactly is a node. So a node is a Docker engine and a member of the swarm. There are 2 types of nodes, managers and workers. And really, this distinction is just, it's all runtime, right? So if I have an instance and I put a Docker engine on there, and I designate that, hey, this is a node in my swarm, I can say this is a manager node, or I can say this is a worker node, but I didn't have to install a separate Docker image. I just did it at runtime for configuration. And yeah, so a manager node basically schedules service tasks on worker nodes. So I have that service again, that service is called Ian, and I want 5 replicas, and the manager is responsible for taking that service and then scheduling those 5 tasks on the worker nodes throughout the swarm. One thing to note here is that manager nodes and worker nodes are both capable of executing tasks. This is actually pretty cool because if you're in a, an environment where you need those 3 Docker managers to be fault tolerant, but you don't really need more than that. Those managers are perfectly capable of running those tasks as well. You don't have to segregate your managers and your nodes and only use the nodes for running those. And that's the default behavior of the swarm. Maybe you can change that. Maybe you can say, I only want managers to manage.
Experimented on changing that policy. I haven't found a flag that would turn them off.
Yeah, I have not, because quite honestly, one of my goals is basically to get us as dense as possible with cost savings. So at the moment, I don't need to scale that large. So at least initially, I'll probably be using my managers as workers as well initially. So yeah. Okay, so yeah, demo time. All right, so the first thing I have here is just, this is some Dockerception going on here. So I'm using Docker Compose to basically bring up Docker and Docker containers so that I can show you, a full Docker swarm here. If you're not familiar with Docker Compose, this is a way that I can define multiple Docker services to be brought up, and I'm just saying, hey, I need a manager here, and it's an image, a Docker and Docker image. I need a worker, it's a Docker and Docker image. And the primary distinction here is on the manager, I'm exposing the Docker API port so that I can connect to it with my local Docker CLI. And then I'm also going to expose port 8080 and 8080 on the worker as well. And if you can kind of envision, hey, I may have like an external load balancer or something like that. That's where I would want to expose that port. And I'll get to that piece a little later and show you exactly how it's used. But yeah, so the first thing that we'll do is basically we'll bring this Docker swarm up from the Docker Compose file.
Can you increase the font size just a bit, please?
Yes. How's that? Better? No?
Yeah, that's fine.
Sweet. All right. All right, so let's see. So in here, yeah, so this Docker Compose file is basically what you just saw on the slide. So I'm going to do Docker Compose up, and I'm going to run it in the background. So what I did here is I created a swarm manager, and I created a swarm worker. So if I do a Docker Compose, and I look at the processes here, you can see I've got my swarm manager. I have my ports that are exposed back to the host, and my swarm worker here. So that part's pretty simple. Now we basically have two containers up, and let's just not even think of these as containers. Like, think of these are, Amazon instances or virtual machines. So I have these instances, and I have two copies of the Docker engine on them, and there's really no difference between them except the ports that are exposed. So at this point, there is no distinction between a manager and a worker as far as what's actually running on it. Okay, so the second thing I'm going to do is once the video comes back, I'm going to initialize the swarm. So I'm doing this through Docker Compose just so that I can get to it more easily, but uh-oh, it does not let you highlight. All right, we may have to roll like this. Can everyone still read that? Yeah. Yeah, okay. This will work. Okay, so what I'm doing here is I am, all right, so I'm basically initializing the swarm. So what I did is I said I want my manager to be a manager. Man.
Managers are flaky.
They are flaky. Okay. All right, so yeah, now that I have my manager up, still good? Let's see. Yeah, so I just want to talk really quick about acceptance. So I have a manager, but I need to bring that worker into the swarm as well, right? And the default behavior of the new version of Swarm is to automatically accept workers into the swarm. So if I run a command that says, join this swarm worker to the swarm manager, it's automatically going to do that. If I try to join another manager to that manager, then I'm going to get prompted to manually accept that. There is a way that you can get around that. You can auto accept. So I'm going to go ahead and do that. So this is interesting. This is not actually in the documentation, but this is where GitHub comes in handy. So basically in the documentation, it says you can auto accept a worker, manager, or none, but it doesn't say you can do an all, and you can't put a comma between them. So what you have to do is you actually just have to put both flags in the command line. So you auto accept worker and auto accept manager. All right, so So now my swarm's been updated to auto-accept the workers and the managers. Now this is a little dangerous, right? To bring managers in without any kind of authorization. So what I could do, and I'm not gonna do it here, it's not in my demo, but there is an option where I can set a secret on them as well. So actually in a production version, well, not production yet, but in the road to production version that I basically have, you know, like a 64-bit key that's randomized that is put into the launch configuration for the auto-scaling group to you know, it basically inject that secret in there so that when it connects, it has to have that key value, otherwise it won't accept it. And that's just a little bit of added protection. All right, so now that I've updated this, I should be able to add some workers. I went ahead and just threw together a little script because I was lazy and I was playing with this and I didn't want to like paste a whole bunch of stuff in. But basically all I'm doing here is I'm telling Docker Compose to scale my worker nodes up. So I'm creating more of these instances. And then I've just got this little loop that basically tells the swarm to go ahead and join the managers. And it just like, you know, that way if I say there's 10 of these guys, it'll iterate through that and bring all 10 into the to the swarm. So I'm going to run that real quick. And I'm going to scale the worker. And I'm going to scale this up to 4 workers. All right, so now if I do Docker Compose, yes. So now I have my manager and I have my 4 workers. So now I got a pretty nice size swarm here. Okay, so yeah, so what I want to do next, I want to actually interact with this swarm. So let's make this bigger. Okay, let's see. So I have this environment file, and basically all I'm doing is setting Docker host here. So if I look at Docker host, I have this set to the manager, and now if I run like Docker info, you can see that this is operating within the containerized version, and you can see the swarm here is active. It's manager. There's 5 nodes. So there's a command here where I can say Docker node list, and there's all my nodes. So I have my manager there, which is the leader, and then I have my 4 workers all ready to go. Okay. I'll try not to move my laptop much. Okay, so at this point, yeah, I want to get something on there. I want to go ahead and create a service. That's how I'm going to interact with my swarm. So I'm going to say Docker service create. I'm going to give it a name. I'm going to expose ports, and then I'm going to pull down this container. So what this container is, I'll just show it to you real quick. I was trying to figure out, hey, what's a good way to demonstrate this? And this container is this Docker file here that pulls in Nginx, and then basically runs the shell script, and the shell script goes out to proc, and it just retrieves the ID of the container itself, and then shoves that into index.html. That way I can show you guys as we're going through the load balancing that, hey, these are actually load balancing through multiple containers. All right, so I have that already pushed up to Docker Hub. So I'm gonna go ahead and create the service. Okay, so now that I have my service created, I can take a look at it. So I can say service inspect. And you can see in the service, you know, hey, here's my image, and it's a single replica. There's only one of them. Here's the port that I was exposing, and here's that internal virtual IP as well. All right, so now I should be able to run Docker service tasks, Swarm Hub, and I should be able to see that single task that was executed. All right, so there's my single task. And the interesting thing, at least it should be, if you do Docker node ls, and you match these node IDs up, you can see that it is actually running on the manager there. So just kind of proof that, hey, yeah, you can actually run tasks on the manager as well. Okay. I don't know, because honestly, I just haven't looked into it. Because like I said, I think I'm going to use managers for tasks as well. But I would think that that would probably be, if it's not there today, you'd think it would be an option that they'd want to have. Okay, so now I'm going to scale this, and it's actually very simple to scale. So I'm going to say Docker service scale, and then the name of my service, and then I want 20 containers. So let's take a look at the tasks again. So we've got this single task here, and then I'm going to scale this guy, and now we got 20 of these. And you get a couple things here. You get a last state and a desired state. So our desired state is all of these should be running, and then I know this is kind of cut off here, but the node ID is right here. So you can see, hey, these are nicely distributing between the 5 nodes that I have. You see 450, AB6, D70, F0. So yeah, I'm definitely getting distribution. Now this is going to take, some of them are running already. This image I think is about 60 meg, so it may take a few more seconds here. All right, so this is probably going to take, I don't know, maybe like 30, 40 more seconds. Is there any questions while we got this little pause?
You're running this, Brad.
Yeah, so by default, and you should be able to see that. Let's see. Swarm inspect. So in Docker Swarm inspect, I believe it's in here. Oh, I'm sorry. I think it's actually in the service. You know what? I'm not sure where that is. Is that? Yeah, I thought I'd seen it at some point. I'm not sure where that is. I remember seeing it at some point doing this testing, but I don't remember where. I would have thought it would have been in Swarm. Yeah, sorry, not sure.
Strategy flag in the swarm management.
Yeah, I mean, I would have thought it would be in either update or initialization.
When you created the manager, did you have to specify?
Oops. No, you tell it you want to join as a manager.
Could just be that the help that you're looking at isn't updated.
That is possible. Yeah, I swore I saw it at some point. But yeah. Okay, so let's see. What do we got here? Okay, great. Hey, everything's running. So let's do, before we move on to reconcile, let's see that this actually works. So once this comes back. So I'm just going to grab this port that was exposed to the host here, and I'm just going to curl this guy, and we should see different container IDs coming through. So yeah, we know that the load balancer is working, right? So we're accessing a single port through that manager, and it can be the worker as well. It doesn't have to be the manager. And it is load balancing between the different containers that are running. So those 20 tasks it's rotating through. All right, so now let's do, let's kill half the workers and see what happens. So yeah, we're running, we're looking good. So let's go over here and let's scale the worker down to 2. So we're gonna remove number 3 and 4. That wasn't intentional. I'm not hiding the magic, I swear. Okay, so you can see here things have changed, right? Instead of everything running, you have some of these accepted, some of these preparing, accepted, preparing, and as you keep refreshing on this, you should see that everything starts to reconcile. Yeah, so now everything is, right? So it's all running, and you can see some are running for 4 minutes, some for 23 seconds. So those are the new containers that have rescheduled themselves across the, the surviving nodes within the swarm. Sorry? Yeah. So basically, there were 4 worker nodes, and the Docker Compose scale worker equals 2, strip 2 of them out. So they just up and died.
So
and
that shows that rebalancing of the workflow that were those back to the ones that are still there.
Yes. And I should mention that at least today, that is the only condition on when these will rebalance. They don't rebalance themselves based on like load or anything like that. It's based on failure. So you got a node that dies is going to reschedule somewhere else. If you add a new node to the swarm cluster, it's not going to automatically like rebalance or anything like that today. I'm sure that's probably coming. All right, so so we did a reconciliation there. Tasks were redistributed across the swarm, and they met the desired state, which was running. All right, so rolling update. So I added this like, I don't know, 10 minutes before the meeting started, so I haven't really, we'll see if this works. So rolling update here. That is a disclaimer. All right, so what we're going to do is we're going to update the service, and we're going to update it with 2 flags here. And one of them is update delay 10 seconds and update parallelism 1. So what I'm telling it is that I want to have a 10-second delay for each task that I have in the service before it updates to a new version of the image. And then my parallelism is 1. I only want to update 1 task at a time. Now, someone was asking earlier, could you update half of this and see what happened? I don't see, if you had like 10 tasks, I don't see any reason that you couldn't, set the update delay for like 24 hours and make the parallelism 5. I mean, then you got a 24-hour window to check things out. I mean, technically that should work. I don't know, never tried it. Barely tried this. So, all right, so we'll punch this in. All right, so now I've updated, and let's just make sure my tasks are still running here. And what I'm going to do is I'm going to update this with version 2 of my image. And we'll see what happens. All right, so nothing yet. All right, there's one. Start it up. Lose you. And this is 10 seconds, right? So it's going to take a little before all these balance in. But let's see if we can get another one. I should have made it faster. I'm curious if you can like override that. But all right, so there's a second one. So let's try a couple curls. If we get lucky, we should see a version 2. Oh, there we go. So there's version 2. So that's my rolling update. So every 10 seconds, it's going to replace one of those tasks within the service, and I've got a nice slow rolling update in my cluster here. All right, and let's see. Oh yeah, I just threw this in. I know Lee had a slide on this. I was just going to fill this up with like miscellaneous things, tips and tricks, etc. The global was kind of cool. If you had basically a container that had to run on every single node within the swarm, this would be a good way to do that. Maybe you got something that's collecting metrics or doing your logging or something that you have to have on every single instance. Global is a nice, easy way to throw it out there. And that is pretty much it. So feel free to tweet me if you got any questions. And anybody got questions at the end? Yes.
When you were doing the rolling upgrade, is there a way to set a health check there? So if your first rolling upgrade fails, it'll just stop?
That's a good question. So as far as I can tell, yeah, sure. So the question is, if you're doing a rolling update, is there a way to stop that rolling update or have some kind of health check that basically says, hey, if this update failed, this health check failed, stop the rolling update. So as far as I know, those 2 flags that I showed you are the only ones that I could find that are applicable to a rolling update. I haven't seen anything else. I don't know if you issue another update command. I guess if you issue another update command back to the original image and set the delay for like 1, then that's a really quick way to get it back. But yeah, I haven't yet experimented with the health check feature and kind of seen how it integrates with Swarm. But that's a good point, good question. I'm sure it's something that I'll be looking into soon.
I did a rolling update, and then about 25 seconds into it, I forced another rolling update back, and the original one stopped and started rolling them all back.
Okay, okay.
So, but I only did it a couple of times this afternoon.
So it doesn't like queue up or anything. It basically just says, hey, here's a new config, get it back to this state.
I don't know what happened to the old one.
Okay, yeah, it probably just discards it at that point. Any other questions? Yes.
For the mode, is it global or something like that? It just puts one in each case. Can you access them? Do you have to access them by the IPM port, or can you use like link?
So in this example, basically the service itself, I was publishing port 8080 back out, and that internal routing mesh was basically taking the load and distributing it across, right? So that's how I was able to access that service. Yeah, I mean, as far as getting to the individual containers themselves, like you'd have to launch something else within that same overlay network to be able to touch those other IP addresses.
And would you send that URL to your slides to Lee so it can be posted on the meetup?
Yeah, I'll post it myself on there. I'll throw it up in the comments. Yes.
So when Lee did the presentation about IPPS and how is it going so that even though the HA proxy only accesses the node per se, any of those nodes can route to any of the containers across the entire cluster? Is that how you?
Yeah, so if I go back here and I look at my, what survived within this, I was using the manager, but I could just as easily go back here and, oh shoot. What was that? 32780. I should be able to get the exact same effect from any of these guys. So the idea here is in production, I mean, basically throw all your nodes behind the load balancer and then say that's, hey, this is my Nginx service for my website, and it'll route the traffic through any of those nodes to that port. But yeah, the internal routing mesh will basically get you the same result on any of those nodes. Yeah, that was kind of neat. I did like what Interlock did with the host header stuff. I thought that was kind of cool. Like you could have a single load balancer and then base everything off your host header. I kind of wish that they would throw that functionality in here as well, because that was really, really cool. Like in my example, if I have like 20 clients and I've got like client1.reflectionhealth.com, client2. It was able to basically look at the host header, say this is client 1, and route it to the appropriate group that represented that client. So that was kind of a neat feature of Interlock. And my understanding is they're actually using Interlock under the hood here for the load balancing. So maybe that's a feature that they'll incorporate into here. I thought that was neat.
Did you create a GitHub issue on it?
Yeah, yeah. There's pros and cons on it for sure. I mean, it's the disadvantage is there could be maybe some scaling issues there. You're throwing a lot into a single service like that versus this way you have a port for each tenant. So I don't know. I like the idea of the flexibility to experiment with both at least. So.
Where did you get that impression that Interlock's under the hood here?
I saw it on the slide in it was one of the breakouts where they were doing like a Swarm 112 deep dive, and they had on the slide it said like Interlock. And then I believe I spoke to one of the Docker folks I spoke to as well. I don't remember. One of them I was talking about Interlock, and I think he kind of alluded that there were still some pieces of Interlock in there. I know Interlock was written by someone at Docker, right? So I don't know if it's like Interlock itself is thrown in there, or if they just like took some concepts and some ideas from there. But yeah, I saw it on one of the slides though. I have no proof though.
Just curious.
Can you throw this on Amazon?
Yes. Yeah. So so a lot of this was, I basically, after I came back from DockerCon, I was like, hey, I need to go back and look at all my code and figure out how to, throw this back in. there's a couple things that are exciting that's coming from Amazon. One, it's funny, like the day that they announced the Docker data center for Azure, like Amazon kind of silently announced that they had a CloudFormation template for that as well. So you can actually go out and there's a CloudFormation template for Docker data center, and it's got some nice little tips and tricks in there in that CloudFormation file. The other thing is they announced that they're going to have a Docker for Amazon beta, and like literally just, I don't know, 2 days ago, somebody wrote a really nice blog post, and he's got a diagram of what that infrastructure looks like. It was a little interesting to me because, and I could be wrong, I think there was like some DynamoDB in there and some SQS in there, and there were some components in there that made me interested in like how they were utilizing those. But you know, you can all sign up for the beta, and I got an email saying that they got my submission, but I'm not in yet. So anyway, so that'll be interesting to see how they're doing things, because a lot of this stuff was very easy to get into Amazon. You know, my existing infrastructure code is based around primarily Terraform, and I've got some Packer in there, some Ansible, and you know, a lot of this was pretty easy to migrate into that. There were some things that were interesting, like, you know, my auto-scaling group is configured to have the swarm managers join an existing manager, but you still have to have a step where you're initializing the swarm in the first place. So I'm curious how Amazon resolved that issue. So I'm still experimenting, still playing around, but I mean, so far it worked beautifully.
Can you also post that blog post link?
Yeah, definitely. I will post that. Let me throw that in my note here. Any other questions? No? Cool.